Today I'm going to talk about network operations part. So basically any query that is made by a user will be routed to, will be first served by supervisor agent. The supervisor agent will decide whom to delegate the user query based on the intent. So let's say the intent of the user is to show the state of the network. Say what interfaces are available in the network, what network instances are available in the network. The agent will be routed, the query will be routed to the show agent, and show agent will query the devices, parse it, and then show it to us. Okay, if the query is related to, let's say, configuration change, it will try to understand what the user really wants. It will create a plan based on the tools available, and then ask whether or not the configuration change should be applied. So it will basically ask for an approval. Next, we have a reporting agent, and the job of the reporting agent is to query an NMS. There's an NMS integrated with this network environment, and the NMS will get stores historical data, and it will fetch the historical data and show a nice graph. Okay, so each agent has its own system prompt, and each agent each agent has access to certain tools which they need. So even by mistake, there is no way for an agent to make configuration changes. For example, you don't want any network changes if your intent was just to view some commands, the state of the network. Okay, let's get started. So this is what the interface looks like. There is also a topology. You can see what the topology looks like. You just need to load the topology, and it will show you what it is. So the green links here indicates that the interfaces between the leaf and the spines are verified based on is verified. So it's using LLDP protocol to make sure that the topology is actually what it looks like. Okay, and the reason why there are also clients connected over client 1, client 2, client 3, but the reason why the clients are red is because there's no LLDP running between them. Okay, but it is in reality connected to each other. Okay, now let's go to the chat. Now under the configurations, there are devices which are involved. So there are only 5 devices: leaf 1, leaf 2, leaf 3, leaf 4, and leaf 3, spine 1, spine 2. And for each device, the protocols that will be used is also mentioned, and the ports exactly that needs to be used. You can even add new device if you want. Okay, by obviously filling this form and just put add device. Okay, right. Now the InfluxDB is the NMS that will be used for this demo, and the credentials, and which large language model you would like. There are a list of large language models over here, and obviously each large language model will cost you a certain amount. So DeepSeek is relatively cheaper and also pretty good. So for this demo, I will be using DeepSeek. Obviously, if you use a much more powerful large language, you will get a better result. So let's get started. Let's begin with a query that is related to reporting. So show trend for CPU utilization of leaf 1 for past 5 minutes. Okay, let's see what happens. So notice that the query has been delegated to reporting, reporting agent. Okay. So the time can vary depending upon the NMS, I mean the resources of the laptop on which you're running. So all the services, network topology, including the NMS, is running on the same system. So you can expect some delays. Also, it depends on the LLM chosen. Okay, so let's see. So it managed to get raw statistics. Now it's showing you the analysis of the statistics, and finally what the graph looks like. So it's plain 6% utilization, and it's saying that the performance is low. I mean, the CPU utilization is low, and there's no issue at all. Okay, let's make another query. Show trend for memory utilization of, let's say, leave 2 for past 5 minutes, just to reduce the number of samples, because it can add to the delay. Okay, let's see what happens. Let's wait for the response. Okay, so we have a response. Okay, so according to the performance assessment, the 76% utilization is reasonably operational. 76 is high. Like, it's because I'm running it again on a laptop. So it's using 76% of the memory, but it is consistent since there is no traffic. Okay, so that's what reporting agent looks like. So now let's make it's that the next query is not related to the previous query. It's always better to clear the context, so that so the previous context, clearing the context will help us save some token. So let's clear it. Okay. Now let's make a query that is related to show command. A show show the network instances available on leaf 1. Okay, okay, let's do leaf 1, leaf 2, and leaf 3. Okay, let's do this. Let's see. Okay, one thing is really important here. Now it has delegated it to the show agent. One thing that is really important here is that there are no fixed functions running behind the scenes. So all it's doing is this agent is trying to figure out which device needs to be queried. It's trying to figure out what the intent was, and based on the intent, it's deriving the path of within the Yang model for which it needs to make a query. Okay, so you can pretty much ask any question as long as there is a Yang path that can respond to your query. Okay, so let's see. So behind the scene, it understands that the device that is being used is a Linux, and the version is 24.7.2. First, it checks what the capabilities of the devices are, and then once it knows the capability, it then goes through the Yang model and tries to figure out the path that can respond to the query, and then generates a request against that against the path. of the Yang model. Okay, the agent is now driven instance configurations. Okay. And by the way, you can also view more details of what is going on behind the scenes by viewing the logs. Hold on, if there is any way to see it, just give me a second. Okay, so let's say let's go here, ls grid logs, cd logs, and you can cat over here to view exactly what happened when the query was made. Okay, right, let's go back. Okay, seems like it's stuck somewhere. Let me ask it to continue. So the behavior can change based on the model you're choosing, because I'm trying to save some token cost. So I used a relatively cheaper model. To have a better experience, you could choose a much more powerful model like GPT-5 or Sonnet. Okay, so let's see. Okay, so now we have something here. So it says that network instance available here is just okay, so there are two network instances. One is default, the other one is management, and the default is of type default, and the other one is of type IPVRF. So basically there is, on all three, the configuration is consistent. Okay, so you could also do something like what ports, what interfaces are in upstate on what, let's make it more specific, what Ethernet interfaces are in upstate on leaf 1. So it's doing the same thing. It's trying to figure out which path can respond to your query, and then it will figure out the path and then create a Gemini request. Okay. All right, so it managed to figure out where it can find the details. So there's an Ethernet interface, one Ethernet interface that is connected to other device, and I mean this is what it looks like. Okay, right, now let's now move on and try to configure something. So we have seen what the reporting agent looked like, what the show agent looks like, and notice that it did not ask for any approval or anything like that, because it's not network, it has no impact on the network. So this time I'm going to try to make some configuration changes on devices. So let's do that. So create a Mac VRF with ID 100 on leaf 1 and associate interface Ethernet 1/10.100 with it. So let's see. You can even enable debugging to get some additional data, additional information of the session. So for example, let's enable it and see what happens. So it's just showing some additional information, but apparently for this session it doesn't seem to be very helpful. Okay, let me disable it again. Okay, so it created a configuration plan. So it just took my intent and then created a configuration plan. Now it's asking me to approve the plan. So as an SME, I need to know what this plan will do. So I can see that it's asking that it wants to create a Mac VRF with ID 100, and then it wants to associate an interface with it using a certain tool. So let's approve it for now. So ideally, once the configuration is applied, the Mac VRF should be created. So now it's delegating the configuration change to config agent. Okay. Okay, let's do that. Let's see. So ideally, it should show over here that the network instance been created. Notice that there was no Mac VRF 100 before. Now there is a Mac VRF 100. Next, did it like associate an interface with it? And yes, an interface has also been associated with it, which is what we wanted. Now let me go back to the topology. Okay, so I need to click here to view the topology. Okay, so here you can see that there is a client 1 connected to leaf 1 and then client 2 connected to leaf 2. Now the client 1 is configured with a VLAN of 100 and the IP 192.168.100.1, and client 2 is also in the same subnet but on a different leaf. Okay, so technically, in order for the two to communicate, the VLAN should be extended. It will be extended through, obviously, EVPN is running under the hood, so it will be extended through EVPN route type 2. Okay, so as of now, the ping from client 1 to client 2 should not work because there's nothing configured on leaf 2. Okay, let's go back. So now it's saying successfully created VRF, Mac VRF1, Mac VRF over here, and it has also verified the configurations, and we saw that it is kind of working. Okay, so let's go back to here, and let's see what is configured on device. Notice that 110.1 is configured over here. If I ping 192.168.100.2, it's not pingable, which makes sense, but I should be able to learn MAC address here. Show network MAC, let's say bridge table and MAC table, and then is there any MAC address over here? So I am learning one MAC address. So let's ask the same thing from the bot. Are we learning any MAC address on Mac VRF 100 on leaf 1? Okay, let's see. So now again it's delegated it to the show command, show agent, I mean, since it's just show related query. And yeah, so it's saying that let me present the MAC address learned on the VRF, and this is the MAC address that was learned. So let's just copy it just to make sure that nothing funny is happening. Yeah, it's exactly the same. Okay, now in order for the ping to work, we need to request the device to do the exact same thing on leaf 2. Okay. Can you create Mac VRF with ID 100 on leaf 2 and associate interface Ethernet 1/10.100? Okay, so it's now again generating a configuration plan. And let's see. Okay, now again an approval plan. Now I need to approve it. Okay. So notice that the supervisor agent was interacting with the user the entire time until the request was completely approved. Once it was approved, only then the request was delegated to config agent, and only config agent has the ability to make changes in the network. Okay, so it's like supervisor agent is like a security guard who will approve whether or not the request should be forwarded or not. Okay. Let's see. Okay, so it's saying that configuration has been completed successfully, created over here has been associated, all the verifications. Do you want me to do the verifications? Let's don't do the verification for now. Yeah, no, the ping is working, so it should be fine, right? Okay, so let's do one last thing. The client 3, let's go back to the topology. Client 3 is connected to leaf 3, but it's in a different subnet. So in order for the communication to happen between the client 1 and client 3, a gateway should be configured on the leaf, and then leaf 1 and leaf 3 gateways subnets should be in the same VRF, and in as our Linux language it's called IPVRF, so same IPVRF. And then they should be routable through EVPN network. Okay, let's do that. So create IPVRF with ID 1000 maybe on leaf 1 and leaf 3. Okay. Okay, so the configuration leaf 1 leaf 3 is slightly different, so let's not mix it. Let's just say IPVRF 1000 and associate MAC VRF 100 with it. Now I need to mention the IRB interfaces using IRB 0. IRB or Anycast gateway using with Anycast gateway 192.168.100.1/24 on leaf 1. So this is what I want on leaf 1. That leaf 3's configuration is slightly different. So let's see. So now it will delegate it to the config agent once again. Okay, So this is the plan. Get the configurations first and create a rollback, and then configure this. The intent is to create IPVRF, and then the intent here is to associate it. So these are like config device and this config device and rollback. These are tools available to the config agent. So let's do this. Okay, now the configuration has been approved. I'll delegate the execution to the config agent. Okay, let's see. So if it is successfully created, you should see another in-network instance with the name IPVRF. Let's see. Is there or not? Okay, so now you can see that there is an IPVRF available, and there should be an IRB interface like an Anycast gateway configured associated with it. So I can see that there is an Anycast gateway, and this Anycast gateway should be associated with both MacVRF and IPVRF. So if I do this, MacVRF, notice that it's associated with MacVRF as well. Now, in order for this communication to work, so the IP of the client 3 is 3, right? So I need to configure leave 3 as well. Okay, let's do that. Okay, let's just simply copy paste the request. I will associate this, but the difference here is, okay, I need is there any MacVRF on leaf 3? Let's check that first. What network instances, or to make it quicker, let's just cheat a little bit. Let's go here and just check quickly. Okay, so there's no network instance over here, so I can say that create this, and this time, okay, I made a small mistake. It should have been 254 on MacVRF this, and okay, now I need to create a MacVRF first. Hold on. So it's all messed up. Create MacVRF with ID 200 on leaf 3 and associate interface Ethernet 1/10.200 with it. Okay. And once it's done with this configuration, the next thing I need to do is this. Create an IPVRF and associate. Maybe something like this. Like leaf 3. It should be 2.254. And this. Okay. So once it's done, the next thing we need to do is associate IPVRF with the same VRF and associate, but we haven't created the MacVRF yet. So first create, my bad, what am I doing? 254 200. Yeah, I think it's fine. So create IPVRF 1000, associate MacVRF 200 and with Anycast gateway. This is this on 254, and probably we need to replace the gateway IP of leaf 1 as well. The gateway should be 254, not 1. Okay. let's see. So let's go to the device now and check if it is created. Network summary. So OM is the interface associated with it. Yes, it's associated with it. Now let's do this. Create MacVRF, associate MacVRF 200 with Anycast gateway. Let's do that. Okay. Delegate to config agent. So the first thing is okay, so let me approve it. Okay, so ideally it should create IPVRF. Okay, IPVRF. So interface IRB 200 is now associated with it. Network IPVRF 200 and interface IRB is associated with it. But the ping will still not work, and the reason why it will not work is because the gateway on the leaf one is incorrect. It should have been .1. Show network IPVRF interface. So it should have been 254, not .1. Now let's ask it to replace it. Configuration successfully done. Can you replace IP with 254 on leaf 1? Okay, let's see. Well, let's give it more context so it will be easier for it to search. Can you replace IRB 0.100 IP leaf 1? Okay, so again it's a configuration change. So notice that it's saying that it has to deassociate it and then delete some configuration and then reassociate with correct gateway IP. Let's see. If I go here right now and check the interface. Okay, let's see. It's delegating it, still working on it. Let's see if it works. I'm not sure about it. Okay. It is taking some time. Okay, probably it has deleted it. That's why it's not there anymore. So if you remember from the steps it has to take, first it had to remove the gateway. So it managed to remove it. Now it has to recreate it with correct gateway. Okay, now the ping has started working. Okay, so I think the video is already too long. In the next video I'll talk about the troubleshooting agent, which is quite interesting. Thank you very much.